Good afternoon, ninth period. I regret to inform you that I am participating in a staff development project this period, and so you get to have virtual Mrs. Hayden. And so we begin by talking about composition of functions. Yesterday we had adding, subtracting, multiplying, and dividing functions. Today we learn a completely new operation, or review a completely new operation called composition. And this is kind of like the turducken of functions, because what happens is you evaluate the interior function first, and then you use the output of the interior function as the input for the exterior function. So the composition of the function f with g has this symbolism. It's got that open circle there. That's how you know it's composition. It is not multiplication. And we would read this as f of g of x. F of g of x. Some people say f circle g of x. That's okay, but f of g of x. And then the domain we'll get to in a little bit. So first we want to practice finding compositions using the table. And so we have a couple of functions here. We have function p in the top row. We have function q as the second row. And the first thing we want to identify is the values for function r. R is the composition of p with q. So this first cell would be p of q of 0, which means I got to find q of 0, which is 5. And then that becomes the input for the next one. So then we find p of 5. So this equals p of 5, which you can see on the chart equals 4. Let's go do another one. This time we're going to find p of q of 1. So p of q of 1. First thing you do is you find q of 1. Q of 1 is 2. So 2 gets plugged into the p function, and p of 2 is 5. So that means that r of 1 is 5. So this one we're going to try without writing it out. So p of q of 2. Where am I getting the 2 from? It's from right there. So first I find q of 2, and q of 2 is 3. So then I'm going to find p of 3. P of 3 is 2. Okay, next we're going to find r of 3. So that means first I find q of 3. Q of 3 is 1. I take that 1 and I find p of 1, which is 0. So it would be good if you kind of took a second right now and filled in the rest of your chart. So if somebody would hit pause, that would be great. So please go ahead and check your values against those in the table. Again, this should take a couple minutes. Feel free to pause the video. And it's entirely possible that somebody at your table is catching on more quickly and has the answers right, and perhaps could share with the other ones, you know, how you got those answers. Okay, or maybe you got all of them right and we're just ready to move on. Okay, so we completed that table, and let's go on to the next thing. And this would be doing compositions from a graph. So given functions f and g, so shown below, find first of all f of g of 2. So in order to do that, we're going to find g of 2 first, and g of 2 is about right there. And so then we take that, so that equals 1. So g of 2 is 1, so we're now going to find f of 1. F of 1, according to the graph, is up here, looks like 4. All right, now we're going to turn a little bit, and go in a different direction. We're going to find f of 0, and f of 0 is 4. So that means we're going to find g of 4, and g of 4 doesn't exist, and that can happen. All right, now here's something new. You can actually compose a function with itself. We're going to find f of 1 first here. F of 1 is 4. So then you take that output and you plug it back into f, and f of 4 actually equals 4. So why don't you go ahead, find g of f of negative 3 and f of g of negative 1, hit pause, and come back and check your answer. So go ahead and check those answers. Hopefully everything went okay. And we're ready to move on to the next example. Again, if you're not okay and you need to discuss with each other, then go ahead and take some time to do that. Example 3, we're now going to algebraically find composition of functions. So all the algebra fans in the room, this is your moment. Okay, so we're going to find f of g, g of f, and f of f. So f of g means that g becomes the input for f. So f of g of x would be basically g squared minus 4 times g. And we do some algebra on that. We get 4x squared plus 4x plus 1 minus 8x minus 4, which simplifies to 4x squared minus 4x minus 3. We're going to skip the domain at this time because I would like to be there in person for that. I anticipate that there will be some questions, and I'd like to be around for that. So we're going to put the domain part on pause. That also means on your homework assignment tonight, you can put the domain part on pause. Of course, if you'd like to give it a try, that would be phenomenal, and I certainly won't get in your way. All right, now we're going to find g of f, which means f, whoops, no, come on, give me my pen back. Give me my pen back. Oh, blast. Got to find a pen. Draw. There we go. All right, so this means that f becomes the input of g. So it looks like it's going to be a little easier. So we have 2 times f plus 1. So that's 2x squared minus 8x plus 1, and we're done. Lastly, we will find f of f. Just another notation, which means f becomes the input of itself. It's kind of like a snake eating its tail, I guess. I don't know. So that means you're going to take f, which is this, you're going to square it, and from that you're going to subtract 4 times f. It's like math inception. So we have x to the 4th minus, I'm going to say 8x cubed plus 16x squared minus 4x squared plus 16x. And we can simplify that a little bit. I hope somebody's double checking my math here because I am kind of doing this at Olympic speed. All right, that looks pretty good. So what I'd like you to do then is try B and do the same thing. Okay, so I'm going to hit pause. You go ahead and give B a try. Okay, I got to shout over Mr. Barron's here's announcements. There are the answers for B. I'm sorry, I'm under the gun. I have to get this video done now. You can go ahead and stop at this point and do the relevant homework. All right, you're awesome. Thanks for your patience. I'll see you later. Bye.